All right, so welcome back. Today in this video, we're going to be continuing our Civil FE exam review, focusing in structural engineering. And today, we're going to be looking specifically at structural determinacy and stability analysis of beams, trusses, and frames. So I have some practice problems for you all that are pretty conceptual. And so you're going to need to be able to understand concepts because they will ask you this on your FE exam. And so I want to go through some of them now. All right, so let's take a look at these. Number one says, in the analysis of a simply supported frame, what factor or what factors influence the determinacy of the structure? All right, so let's go through the information that we're given, right? We know that this is a simply supported frame, right? And we're trying to find factors that influence determinacy. Okay. I think I spelled determinacy wrong. It's A-C-Y. See, this is why I like math and not big on writing and all that stuff. All right, so factors that influence determinacy. All right, so what formulas might we need for this? I don't know, but I'm going to search determinacy. Okay. So determinacy, three things come up when I search in the handbook. Okay, so determinacy in a frame, right? What influences the determinacy, or, you know, whether it's unstable, stable, and statically indeterminate, or stable and statically determinate. Okay, so looks like by this formula we have 3m plus r. So m is what members, r is the independent reaction components, j is the number of joints on the frame, and then c would be things dealing with hinges, right? Okay, so we got a simply supported frame. What does that even look like, right? Well, anytime you have simple support, it always just means, no, I don't even like that. I'm just gonna say it looks like this. All right, this is our frame. This is my pin. So simply supported just means it has a pin and a roller at supporting it. So whether it's a beam, frame, truss, whatever, simply supported just means it has a pin on one side, roller on the other. Okay. So what factors influence? So let's look at A, the material properties of the frame. No. We're looking at, you got your members, you got your reactions, and you have joints or hinges. So the magnitude of pressure, there's no pressure involved here. The arrangement of supports, yes. The arrangement of supports determine how many reactions that you have, right? So independent, that's what your reactions are, is based on your supports, right? If you have a pin has 2 reactions and a roller has 1, right? So this is, let me explain that a little bit better and put it in a different color. So anytime you have a pen, you know, that you have it going in you have a reaction going in, we'll just call this A, this B. So you have AX, all right? And then you have another vertical reaction that would be AY, all right? And then at a roller, there's only one reaction, and that's at BY, all right? There are different types of supports, right? You have a pen, you have a roller, you have fixed supports. And with fixed supports, you know, you have 3 reactions. So like with the pen, you have 1, 2 reactions. The roller, you have 1 reaction. With a fixed support, you have 3 reactions. I think I might have went over this in another video, but let's just say, for example, you have a pen, or you have a fixed support here, and then you had a roller. All right. Well, at this fixed support, you have let's call this point A. So you have a AY, you have a AX, but for fixed, remember, you always have a moment at A, all right, or a reaction moment at A. All right, so that's why there's 3 reactions. All right, moving on to, so our answer is C. Moving on to number 2. All right, number 2 says, when analyzing frame structures, what is the primary purpose of method of sections? So whenever you're looking at method of sections, well, let's just talk about the information that they give us. So we know we're looking at method of sections, right? And we're trying to find its purpose, right? Are there any formulas that we can use? Not really. If I search method of sections, right? Something does come up for a truss. It says the method consisting of drawing free body diagram of a portion of the truss in such a way that the unknown truss member force is exposed as an external force. Not very helpful. So you have to have some prior knowledge. All right, some PK, prior knowledge. Okay, so what is method of sections? Well, method of sections basically says, okay, let's say I have a frame, right? Frame structure, and it looks like this, right? Okay, and basically you decide to, or yeah, we'll also say the frame does like this. All right, you decide to take a cut of the frame down the middle, right? And so what is happening with this is you're taking a section, so you're cutting a section out, and in return, when you do that, this is what it looks like. All right, got here, got here, got here. All right, that's what one of the sides look like, right? And each of those, there are some forces that take place inside of, from that cut. All right, and that's what we're trying to find, right? If that makes, this is your blue line, right? And so there's a force. I'll just say this is, basically there's forces at each of the arrows. So just something to note. Okay, so now that you have that background knowledge, right, this is something that you need to remember. You also have to do method of sections and method of joints for different trusses in the static section. So if you haven't gone through that, then definitely check those videos out. Okay, so is it A, to determine the overall structural stability? No. What about B, to calculate external loads on the frame? No. External loads would be like this, reactions, right? You got roller, you got a pin, reaction, and a roller reaction. And so those would be your external, any external loads or just information. Okay. To assess internal forces within specific sections. They even use the word in the answer, but that's going to be your correct answer. Internal forces. Method of sections, you're cutting something. Internal forces. Method of joints, still trying to find internal. You're using internal forces and calculating internal forces. All right, let's look at number 3. So let's see. All right, number 3 says, in a truss structure, what contributes significantly to overall stability? Okay. So let's take a look at this. If we look at what information we're given that is a truss structure. Okay. And we're trying to find what really contributes to stability. What contributes to stability? All right, so what formulas might we need? So stability, this, I'm going to search determinacy again because that's the section that we're currently in, but stability is also part of that. And so if you search stability, you should still get to this section. And you're looking at it from a truss perspective, right? So we're going to be looking here for a plain truss. Static analysis, the way that you can determine the stability is all determined in here. So it looks like members is M, R reactions, and J joint. So those are going to contribute significantly to whether or not it's stable or unstable. So material strength of truss members, no. Arrangement of joints and members, yes. Truss span length, no. External factors. So answer would be B. All right, so that concludes a structural determinacy. Few conceptual questions kind of went through. Next section, we're going to be looking at elementary statically indeterminate structures. So we'll go through some more practice problems on those. So I'll see you in the next video.